This woman is the mother of mankind, the genetic Eve from whom we all descend. She lived 150,000 years ago in East Africa, and everyone on Earth is related to her. Her daughters and granddaughters will take modern humans out of Africa to populate the rest of the world, the most incredible and important journey mankind will ever make. Genetic tracking for the first time gives us a route map of our journey. With it, we can follow our families of Eve as they travel through an empty world, overcome hardships, separate, and go their different ways to discover new lands. It tells for the first time who we are and where we come from, the most profound questions that have troubled mankind since we first raised our heads and looked at the stars. This new science is a breakthrough. Every one of us can now trace our part in this incredible story. We took samples from these people in Chicago. Our genetic testing will show them how their ancestors traveled the world to reach this destination. $150,000 years ago, the world was in the grip of an ice age. The ice caps have advanced. Sea levels dropped 400 feet. North Africa is a vast desert with small islands of green. On these islands are tiny groups of people. These are the first modern humans, recognizably like us today in physique, intellect, and abilities. We are the same people they were. The brain that first thought of chipping stone tools also took us into space. They are hunter-gatherers, living in widely scattered groups, roaming each year over great distances, sheltering where they can, gathering seeds and fruit. $150,000 years ago, hunting was the key to survival. It explains much about the way the human race developed. Hunting needs careful thought and planning. It needed cooperation, that demanded enhanced intelligence and communication skills. Genetic tracking is beginning to unlock more secrets than we ever believed possible. In just 7,000 generations, modern humans have left Africa and penetrated every corner of the globe. And through the unbroken genetic thread binding us to our past, we can begin to understand why it happened. Archaeologists can tell us in astonishing detail how modern humans lived. But to understand who we are and where we come from, we must look at our genetic heritage. Genetic Eve, the woman from whom we all descend, was not the only woman living at the time, or even the most fertile, but her mitochondrial genes were the most successful and the only ones to survive. Everyone alive today can trace a common ancestral line back to this one woman through a unique part of our DNA, mitochondrial DNA. DNA, the blueprint of life, is our own molecular pin code and uniquely identifies each of us. Mitochondria are tiny structures found inside nearly all human cells. It is separate from the normal chromosomal DNA that dictates our height or the color of our eyes. Men inherit it from their mother, but they can't pass it on. In women, it carries on from mother to daughter, down the endless generation almost unchanged. And this is how we can trace our way back to our genetic Eve and her daughters. So written within it is the history of the world's women, and therefore the human race. Professor Rebecca Kahn was the pioneering scientist who uncovered the first all-important clue.
I started working on human mitochondrial DNA so that I would have some kind of view that was objective, that would help me understand and help other people understand how humans around the world were related.
With this new science, she could. Harmless mutation happens all the time in some part of the mitochondrial DNA, leaving minute markers at every change. These markers are like barcodes and can be read in the same way. Kahn and her team discovered the changes happen at a fairly constant rate. They found the groups with the earliest markers were the Africans living inside Africa, and wondered if they might be the oldest people in the world.
I was very excited when I first started to get evidence, and it was so counterintuitive. I'd put 20 Europeans and 20 African Americans on a sheet of X-ray film, and every African American showed differences, and all the Europeans looked the same. And I thought I'd mislabeled something, or I thought I'd made some drastic mistake. And we kept repeating and repeating things, and as we got more samples from different areas, I realized that it was a difference in the pattern, and that this whole new type of evidence based on mitochondria was going to change the way we thought about modern humans.
In 1987, Kahn and her colleagues published a paper showing for the first time that the markers stretched back to Africa, showing quite clearly that this was the birthplace of the human race. New Guinean tribesman, Parisian bartender, American teacher, Polynesian farmer, all were improbable relatives linked through one black woman 150,000 years ago. Their findings caused a sensation.
The responses of people were sort of amazing. The public was genuinely interested in certain aspects of it, but there was a a tendency to misinterpret the data because of the terminology used to describe this woman, African Eve. And people thought it meant the biblical Eve, the single woman in the Judeo-Christian Bible of the wife of Adam. I have to say, even my own uncle sent me a Christmas card the year that our study was published saying, "How dare you, you know Grandma wasn't black."
Her work is rewriting human history. Through it, we now know the first mutations took place in Africa, maybe 150,000 years ago, and belonged to our genetic Eve. Professor Christopher Stringer, Britain's leading paleoanthropologist, was involved in the dating of the earliest modern human skulls.
This skull is as close as we can get to what the face of mitochondrial Eve would have looked like. It's a very complete skull found in sediments in a cave dating from about 120,000 years ago. And we can see here that it's a modern human. We've got a high rounded vault to the skull, a face that's tucked in under the cranial vault.
And this is what she looked like. Using forensic reconstruction techniques, muscle and flesh have been added to the skull and provide us with the very first glimpse of how our genetic mother might have looked 150,000 years ago. This is the closest we can get. Africa is the birthplace of all the various human species to walk this planet. This vast, isolated natural laboratory molded humans over endless cycles of alternating desert and green. And it is the climate records that give us the next clue. Modern humans made many attempts to make the long trek out of Africa, settling in different parts of the old world, but they did not survive. Climatic records indicate a brief but devastating global freeze-up at the time that turned the whole Middle East into extreme desert. Trapped in the northern corridor by the Sahara, there was no return and few places to take refuge. Neither they nor any of their lines survived. They would die in severe drought about 110,000 years ago. Their bones were discovered in Kafse caves near Nazareth in Galilee in 1933. 13 fragile skeletons, one a woman, a tiny baby at her feet. When these bones were first uncovered, they were the oldest complete modern human skeletons ever found.
The numerous skeletons that have been found in caves in Israel at the sites of Kafse and Shkul show us that there were modern humans outside of Africa over 100,000 years ago. Those modern humans may well have gone up the Nile corridor through Sinai and into the Middle East, but it doesn't look like they went any further. In a sense, they were a dead end.
It would be 40,000 years before they would try again. 80,000 years ago, the world was cooling down again. Once again, the ice caps were advancing, drying out the lands. Life became much harder. As Africa dried up, so did the drinking water. Ocean records show sea levels dropping dramatically as the world's water became locked in ice. As the game spread north, our hunter-gatherers were